All right, in problems 5 through 11, we're going to be looking at both the double angle formula and the half angle formula for each of sine, cosine, and tangent. All of those are listed here. The double angle formulas up on top. So anything that's sine, cosine, or tangent of 2u will be a double angle. The half angle formulas, cosine of u over 2, sine u over 2, tangent u over 2, listed in the second half of the table. And a quick note on these formulas. The double angle formula for cosine has 3 different options. Here, here, and here. Where we can either look at cosine squared minus sine squared, or 2 cosine squared minus 1, or 1 minus 2 sine squared. All 3 of those come out to be the same answer, so you can use whichever one is most convenient at the time. Also, the tangent half angle formula also has 3 different options, where again, use whichever one is most convenient at the time. Usually for the tangent half angle formula, one of the first 2 is most convenient, but your mileage may vary. One other note on all of these formulas, everything in the formula, when we actually do the computation, so everything to the right of the equal sign, is all based on an original angle, which in this case is labeled u. So what we'll do is we'll take some angle that we know, and when we look for the cosine of twice that angle, or maybe the sine of half that angle, we're going to express that in terms of a sine, cosine, or tangent value from the original angle. So when we're looking at the cosine of 5 pi over 8, that's going to be half of some other angle, and I'm going to look to express cosine of 5 pi over 8, which is not an angle I know, in terms of some other more familiar angle, which we'll work on finding now. So, first thing I'm going to do is actually identify which quadrant 5 pi over 8 is in. So 5 pi over 8. Well, 5 over 8 is less than 1, so 5 pi over 8 is less than pi. And also 5 over 8 is more than 1/2, meaning 5 pi over 8 is greater than pi over 2, which means that 5 pi over 8 should be located in the second quadrant. Next, I said that I wanted to express 5 pi over 8 in terms of a more familiar angle, hopefully something off of the unit circle. So 5 pi over 8 is the same as 5 pi over 2 times 4, where I decided to change my denominator to 2 times something else so I could turn this into a half angle formula. In fact, anytime I've got a something pi over 8, I'm going to look to use a half angle formula, just like in the last section where we saw that anything pi over 12, we tried to use a sum or difference formula. But here, I want to then express this as 1/2 times 5 pi over 4. Meaning that the cosine of 5 pi over 8 can be rewritten as the cosine of 1/2 times 5 pi over 4, so that I can look at a half angle formula for cosine, which I will pull from up here. So the cosine of 5 pi over 8 should be the same as plus or minus the square root of 1 plus the cosine of 5 pi over 4 divided by 2. Now, because we're in the second quadrant, which was the first thing that we looked at, getting 5 pi over 8 in one of the 4 quadrants, I know that cosine is negative in that quadrant, so I'm going to take the negative square root. So this will be negative the square root of 1 plus negative root 2 over 2 divided by 2, which after some simplification, this comes out to negative 2 minus the square root of 2 over 4. So just multiply top and bottom by 2. And since 4 is a square number, looking at negative square root 2 minus square root 2 over 2. So that's a square root within a square root. All right, in problem 6, we're going to look at the sine of 13 pi over 8. Just like we did in the problem before, I'll find a quadrant for 13 pi over 8, where here 13 over 8 is going to be less than 2, but more than 3 halves, meaning that 13 pi over 8 is in between 3 pi over 2 and 2 pi, which should put this firmly into quadrant 4, or at least theta over 2, or u over 2 is going to be in quadrant 4. Continuing on with the same steps from the previous problem, I'll take 13 pi over 8 and rewrite it as a fraction that has a multiple of 2 in the denominator, or a factor of 2 in the denominator. So this will be 13 pi over 2 times 4, just like we did last time, so that this is 1/2 of 13 pi over 4. Meaning that the sine of 13 pi over 8 can be rewritten as the sine of 1/2 of 13 pi over 8. So I can come up to my formulas and use the half angle formula for sine. So I'll want plus or minus the square root of 1 minus the cosine of 13 pi over 4 all over 2. One final step before we get into the arithmetic. We take 13 pi over 4 and subtract 2 pi from that. 2 pi would be 8 pi over 4. We will get 5 pi over 4. So 13 pi over 4 is coterminal to 5 pi over 4. Also, since we learned that our original angle was in quadrant 4 and sine is negative in quadrant 4, I want to choose the negative out of this plus or minus. So when we're trying to select a plus or minus in one of these half angle formulas, we always want to base it on the original angle that we're given. So whatever is originally going into sine, which in this case is 13 pi over 8, I want to make my decision based on that angle. So since 13 pi over 8 is in quadrant 4, I want to choose the negative angle here, which is why I've highlighted that negative sign in red. So this should all be the same as the negative square root of 1 minus the cosine of 13 pi over 4, which should have the same value as the cosine of 5 pi over 4, which will be negative root 2 over 2. So written out in purple because I am going to use that coterminal angle to help me out. meaning that this is the same as the negative square root of 2 minus a negative square root 2 all over 4. And just like in the previous problem, 4 is a square number, so I can take a square root. Meaning my radical doesn't need to be that big. It's the square root of 2 plus the square root of 2. So again, there's another square root inside of a square root. And all of that is over 2. Problem 7. We'll start with the given information that sine of u is equal to negative root 15 over 8, and that 3 pi, or that u is in between 3 pi and 7 pi over 2. And then we'll want to find all 6 of the functions we talked about previously. The double angle formula for each of sine, tangent, sine, cosine, and tangent, and the half angle formula for each of sine, cosine, and tangent. So u is an angle that's bigger than 1 full circle. Since it's more than 3 pi, 3 pi is coterminal to pi, and 7 pi over 2 would be coterminal to 3 pi over 2. We're just going to put our angle u into the third quadrant. So u looks something about like that. We can complete this reference triangle over here. We're just missing the x value. So if we use the Pythagorean theorem, x squared plus root 15 squared is equal to 8 squared. And 64 minus 15 will be 49, meaning that x is equal to negative 7. And negative 7 because we're in the third quadrant. All right. Now, since we're right here and still at the top of the page, I'm also going to go ahead and find the quadrant that the terminal side of u over 2 is located in, even though we won't need that until the second half of the problem. But since we're right here, we may as well. So let's take our original inequality, which is that u is in between 3 pi and 7 pi over 2, and multiply that entire thing by 1/2, since I'm looking for u over 2. So that gives me the inequality 3 pi over 2 is less than u over 2, which in turn is less than 7 pi over 4. So I've even got u over 2 narrowed down to a specific half of a quadrant, but I only really care about which quadrant it's in. So normally quadrant 4 would be 3 pi over 2 to 2 pi, but in this case we know u over 2 is even located in the first half of quadrant 4. Doesn't really matter either way though, because again, I only need to know that we're in quadrant 4, in between 3 pi over 2 and 7 pi over 4. So when we look ahead to the half angle parts of this problem, when we're asked to choose from a plus or minus option, we'll decide based on u over 2 being in quadrant 4. So without further ado, let's tackle these problems. So we can see back from our formula sheet that the sine of 2u is equal to 2 times the sine of u times the cosine of u. So that again, cosine of 2u is going to be based on the reference triangle for u. So we're going to have 2 times a couple of factors. Looking at that reference triangle, the sine of u is negative root 15 over 8, and the cosine of u is negative 7 divided by 8. Multiplying all that together, our double negatives will come out positive. And 8 times 8 is 64, but I can reduce that with the factor of 2 that's in the numerator to get positive 7 square root 15 divided by 32. All right. Then for the next part, I wanted to get the cosine of 2u, which I have 3 different options for. But this time, since sine is my given information, I will use the formula that only depends on sine. I'll use 1 minus 2 sine squared of the angle u. So it should be 1 minus 2 times something squared, where that something should be negative root 15 divided by 8. So we ought to be able to simplify this. So we'll have 1 minus 2 times 15 divided by 64, since that negative gets squared away. 2 over 64 will again be 32. So I'm going to change 1 to be 32 over 32 minus 15 over 32, which simplifies to 17 over 30. 17 over 32. All right, down to the tangent of 2u, which from our formula sheet we have is 2 times the tangent of u over 1 minus tangent squared of u. And that tangent value, which is opposite over adjacent, comes out to the square root of 15 divided by 7. So we'll drop that into both of these two places, meaning that we have 2 root 15 over 7 divided by 1 minus 15 over 49. In this step, if I multiply 49 to both top and bottom to help simplify this fraction so that I only have one denominator, I will get 2 root 15 times 7 divided by 49 minus 15, which, move down just a little, that can simplify to 14 root 15 divided by 34, or 7 root 15 over 17. Okay. Now we're on to the sine of u over 2, which, to recall back to our original part of the problem, we found that u over 2 is located in quadrant 4. And in quadrant 4, sine is going to be negative. So we'll choose the negative out of the plus or minus and fill that in right here. And it's the square root of 1 minus cosine u over 2. So from that reference triangle, I'll grab the cosine value, which was negative 7 over 8. We'll then simplify that as much as we can. Multiplying 8 to both top and bottom. This becomes 8 plus 7 divided by 16, which simplifies to negative root 15 over 4. On to the cosine of u over 2. We are in the fourth quadrant, where cosine is positive. So I want to choose the positive out of that plus or minus. And again, I'll substitute in the cosine of u, which is negative 7 over 8, which simplifies to the square root of 8 minus 7 divided by 16, which will be 1 over 16 on the inside of the square root, or just 1/4. And finally, for the tangent of u over 2, we have the formula sine u over 1 plus cosine u. So we'll fill in those missing pieces. This is negative root 15 over 8 over 1 plus negative 7 over 8. And we'll work on simplifying that. We multiply 8 to both top and bottom. This will become negative root 15 over 8 minus 7, which simplifies to just negative square root of 15. Additionally, since we had already found sine of u over 2 and cosine of u over 2, we could have simply said the tangent of u over 2 would be sine u over 2 divided by cosine of u over 2, and gotten the same answer of negative root 15. All right, in problem 8, which looks rather similar to problem 7, or at least it's the same setup, our given information this time is that cosine of u is negative 8 over 15, and u is in between 5 pi over 2 and 3 pi, which is going to put us in quadrant 2. Since 3 pi over 2 is coterminal to pi, 5 pi over 2 would be coterminal to pi over 2. So we'll do that same process of finding our missing hypotenuse. C squared is equal to 8 squared plus 15 squared, meaning that C is 17. And since the hypotenuse, I don't need to worry about plus or minus. Hypotenuse is always positive. And we'll find an equality for u over 2. So we'll take 5 pi over 2 to u to 3 pi. Multiply that whole thing by 1/2, giving us 5 pi over 4 to u over 2 to 3 pi over 2. And that inequality is in quadrant 3. So when it comes to our half-angle formulas, again, we're going to go to quadrant 3 to decide if I want a positive or a negative out of the plus or minus. Oh, but let's go ahead and look at the double angle formulas first. In sine, I just have to plug in cosine u and sine u, where the cosine should be negative 8 over 15, while sine is 15 over 17. Misspoke a moment ago. That should have been negative 8 over 17. And then we'll simplify that mess. This is negative 240 divided by 289. On to the cosine of 2u. This time I decided to use one of the other double angle formulas for cosine, which is 2 cosine squared minus 1. So we'll plug in cosine, which was negative 8 over 17. And we will get 2 times 64, which is 128 divided by 289 minus 289 over 289, which after some simplification, this comes out to negative 161 divided by 289. All right, then for the double angle formula on tangent, plug in our tangent value, which will be negative 15 over 8, which is just the reciprocal of cotangent, which was negative 8 over 15. And get ourselves a value. This will be negative 15 over 4 divided by 1 minus 225 divided by 64. We'll simplify by multiplying 64 to top and bottom. So this will be negative 15 times 16 divided by 64 minus 225, which after some simplification, this works out to 240 divided by 161. All right, for the sine of u over 2 and the cosine of u over 2. We got that u over 2 is in quadrant 3, which means we'll be choosing the negative out of both plus or minuses. So we'll fill that in over here as well. And also both sine of u over 2 and cosine of u over 2 depend on the cosine value, which is negative 8 over 17. So we'll simplify each one of these. For sine of u over 2, this is negative 17 plus 8 divided by 2 times 17, which is 34. So we're looking at negative square root 25 over 34, which is negative 5 over root 34, which after rationalizing, negative 5 root 34 over 34. Looking at a similar simplification process for cosine of u over 2, we'll have the square root of 17, this time minus 8, divided by 34, which is negative square root 9 over 34. So negative 3 over square root 34, which rationalizes to negative 3 root 34 over 34. Finally, we want the value of tangent of u over 2, which is going to be 1 minus cosine u, which is negative 8 over 17, divided by sine u, which is 15 over 17. Simplifying that as much as we can, so multiply 17 to top and bottom. This will be 17 plus 8 divided by 15, which is 25 over 15, or 5 over 3. Okay, and then in problems 9, 10, and 11, we'll be combining double angle formulas with some other reference triangles more directly. So problem 9, we want the sine, 2 times the cosine inverse of negative 15 over 17. So we're going to call the cosine inverse equal to theta and create a reference triangle for theta. Doing so, we get a reference triangle that's missing its opposite side, but we just saw in the previous problem that 8, 15, 17 is a Pythagorean triple. Or we could use the Pythagorean theorem to do the same thing. Y squared plus 15 squared is 17 squared, so y is going to be 8. And since we're in the second quadrant, we'll choose the positive value there. So I just want to plug in the missing values of sine and cosine into this formula. So sine is 8 over 17, while cosine is negative 15 over 17. And this will work out to negative 240 divided by 289. And in problem 10, we're looking for the cosine of 1/2 of the sine inverse of negative 4 over 5, meaning that the missing side in this reference triangle should be 3, so that we have a 3, 4, 5 triangle. And because this is a half angle formula, I need to know which quadrant theta over 2 is located in. So I will take that inequality for theta, which, since I know it's the inverse sine of a negative number, it should be between negative pi over 2 and 0, since it's in the negative 4th quadrant. So I'll multiply that inequality by 1/2. So theta over 2 is in between 0 and negative pi over 4, which is still the 4th quadrant. And in the 4th quadrant, cosine is positive, meaning this should come out to the positive square root of a bunch of stuff. And the missing value inside this square root, the cosine of theta, should be 3 over 5, which simplifies to the square root of 5 plus 3 divided by 10, which is the square root of 8 over 10. That simplifies the square root of 4 over 5, which would be 2 over square root 5, or 2 root 5 over 5. And then finally, problem 11, the tangent of 2 times the cosine inverse of 1/4. This one's not a Pythagorean triple, so if we look for a missing side, y, 1 squared plus y squared is equal to 4 squared, meaning that y is the square root of 15. And because we're taking the cosine inverse of a positive value, We know that our reference triangle should be in the first quadrant, and that also y should come out to be positive square root of 15. So all that's left is to plug in the missing tangent of theta values, where tangent of theta is root 15 over 1. So square root 15 over 1, which will work out to 2 square root 15 divided by 1 minus 15, which simplifies to negative root 15 over 7. Since 2 over 14, we just simplify to 1 over 7.